How does Amazon ensure stock availability for your favorite limited edition mobile during a sale with a thousand other users also trying to purchase the same product at the same time? And how does it avoid underselling and overselling? For a software engineer to create a robust, high performance system so that can handle concurrent operations while also ensuring data consistency and integrity, understanding concurrency control mechanisms is very important. In today's video, let us discuss the concurrency control mechanisms in a distributed system with real world examples. So ensure to watch this video till the end. Hello everyone, welcome to Tech and Career Bytes. I'm a software professional with more than 20 years of experience, including 7 years in leadership roles at a global product based organization. As you might already know, concurrency is the ability of a system to execute multiple tasks simultaneously. Let us understand two main concurrency control mechanisms: optimistic concurrency control and pessimistic concurrency control.
Optimistic Concurrency Control or OCC.
OCC allows concurrent execution without acquiring upfront locks. It assumes that conflicts between transactions are infrequent and transactions proceed optimistically. When conflicts are detected during the commit phase, appropriate actions such as aborting and retrying the transactions are taken. In a distributed system, OCC is implemented by maintaining version information for each data item. Each transaction reads a consistent snapshot of the database at the beginning. During the commit phase, it checks if any other transaction has modified the same data items it has read. If conflicts are detected, the transaction is rolled back and retried with a new snapshot. In an e-commerce website like Amazon or Flipkart, a common approach to handle inventory availability during order placement without blocking other users is through optimistic concurrency control. With OCC, the order placement flow would be something like this. First, check inventory availability. The system checks if the desired items are in stock. Next, allocate inventory. If the inventory is available, the system marks the items as allocated for the specific order without immediately decrementing the stock availability. After that, set expiration time. A temporary expiration time is set for the reservation. If the order is not completed within this time, the allocated inventory is released back to the available stock. Then comes pay and confirm the order. Once allocated, the order processing continues, including payment and confirmation. Next, update inventory quantity. After payment, the reserved inventory quantity is decremented from the available stock, ensuring accurate tracking. And at the end, release expired reservations. If an order is not completed within the specified time frame, the allocated inventory is automatically released for others to purchase. Here is the beauty of optimistic concurrency control. There is no explicit lock during the order placement process. Instead of acquiring lock and blocking others, the approach relies on allocating the inventory and setting an expiration time. The inventory is not exclusively locked until paid for and confirmed. Others can still view and attempt to purchase the items, but the reserved inventory prevents overselling by marking them as reserved. By setting an expiration time, if an order is not completed within that time frame, the allocated inventory is released and it is available for others to purchase. Optimistic concurrency control strikes a balance, ensuring inventory availability for a specific order while allowing concurrent access without explicit locks.
Pessimistic Concurrency Control or PCC.
PCC assumes conflicts are likely and it acquires locks upfront, taking a pessimistic approach. In a distributed system, PCC can be implemented using distributed locks or lock managers. When a transaction wants to access a resource, it tries to acquire a lock on that resource. If the lock is available, it is granted and the transaction proceeds. If the lock is not available, the transaction waits until the lock is released. There are various OCC and PCC techniques available, and each one of them requires a detailed discussion. I will try to cover few of them in my future videos. Do subscribe to my channel so that you are notified when these videos are available. You can also read about them and other distributed system concepts in the book Designing Data Intensive Applications. One can purchase it using the link provided in the description box. The choice between OCC and PCC depends on factors such as workload characteristics, contention level, and the desired level of concurrency and performance. OCC is often favored when conflicts are expected to be infrequent, allowing for greater concurrency, while PCC is preferred when conflicts are anticipated to be frequent, at the cost of potentially more locking and blocking. For instance, an e-commerce solution may opt for OCC under normal conditions and choose to use PCC when there is a burst in demand for an item on sale, that is, a hot SKU. Or use PCC only when inventory for an item reaches a certain low threshold. In today's video, we discussed concurrency control mechanisms OCC and PCC with real-world examples. If you liked this video, then do check out our other videos. Don't forget to like, comment this video and subscribe to my channel. My name is Rupa and I thank you so much for watching this video. Happy coding and see you in the next one.